This presentation shall be evaluating the research regarding vertical farming, which will focus on the theoretical principles of it and the practical limitations of experimental designs within this subject. The aim of this presentation is to understand what vertical farming is, and from this, understand the different angles of research that vertical farming can take depending on the philosophy branch that the experimental design can take. And then further, we are going to quickly evaluate a case study that applies a pragmatic philosophical approach to experimental design. After this, we are going to look at a potential research topic that can be used, which applies a transformative philosophy approach to further expand upon what vertical farming is and help it integrate through society into vertical farming is a method of agriculture that can be done indoors, and it uses less space compared to conventional farming, which is ideal for urban settings where space is a limited resource, as it can be grown upwards compared to traditional farming, which is generally done on a 2D plane. Furthermore, the plants can be grown in ideal conditions because it can be monitored continuously and controlled through the use of LEDs and using water methods like aquaponics in order to make sure that plants are always kept well watered. However, this does have a downside, is that most vertical farms do not have outside the downside of this is that crops The downside of this is the fact that this also means that you have to continuously use electricity to maintain the vertical farms. And the crops that are generally grown in these farms are crops that have high fast growth rates that can be grown within a month and have high scales profitability, such as herbs, salads, and salad plants like tomatoes, lettuces, and garlic and chili species. It's also important to take into consideration that normal staple crops cannot be grown in these kind of conditions due to the lack of profitability, considering the daily expenses that need to be done in order to maintain these vertical farms. And in addition to this, another advantage of vertical farming is that it is in a closed environment, which means that we can significantly reduce the risk of pests, and we can control the temperature even more efficiently than a greenhouse from heating systems. But once again, this also adds to building a vertical farm. A quick errata to this side, I intended it to mean hydroponics, not aquaponics, for hydroponics is regarding the watering of plants without any additional application of fisheries, which is what aquaponics is all about, which we'll later talk about in the case study slides. There are various axes of research that vertical farming can take, depending on which philosophical research you can take. For example, you can take a transformative approach where you focus on research regarding sociology, for example, of the introduction of vertical farming inside urban cities and how to figure out how to encourage both the local government to fund these endeavours and to also help encourage the population to buy and purchase vertical farmed goods. So, for example, you can, research on what people's views are about reducing overall carbon footprint of food and see how they feel about that, and how you can potentially encourage them through analysing the freshness of food as well. To what you would get from product, because, for example, with chili, for example, a lot of them may have travelled hundreds of miles before entering, or they may have travelled hundreds of miles before entering the city. And then another approach that can affect the kind of research that you get is through approaches that take a post-positive approach, which is the general approach of another philosophical approach that research can take is a post-positive approach, which takes an objective look at data, for example, of trying to improve efficiency of vertical farms in terms of water usage or electrical usage, and trying to improve upon that in order to, one, create a more sustainable farming system, and two, save the money to furthermore increase profitability of crops. And this takes an entirely figure-based approach. The study we're going to study in depth takes a pragmatic approach, and this is what we're going to talk about next. This case study is about the application of aquaponics upon vertical and living wall farms to help grow a wide variety of food. Therefore, they took inspiration from a previous experiment that was done where, as you can see in the diagram, the original experiment took a 2D plane idea where they took 6 vegetable raft tanks and applied piping to it to connect to some filters which attached to fish tanks. From this, any water that comes out and drips out of the plants will go back into a fish tank, which has been filtered to ensure ideal conditions for fish to make sure they do not die, in addition to gas filters, because potential oxygen levels in water can potentially also kill the fish if done incorrectly. And then from this, the fish will also have a connecting gas filter and water filter which attaches to the plants themselves. So the water will also be pumped out and pumped back into the plants themselves to help facilitate their growth by supplying them with water. However, the disadvantage of this is that it's on the 2D plane. So what this study aimed to do was to create a 3D plane of this, and compared to the 32 crops per meter square, which uses this technique, they try to aim to triple potential crop growth, the potential number of crops that are grown from this kind of methodology. They investigated this using 3 experimental designs. The first one used a rather unconventional form of vertical farming, which is using a living wall, which is effectively just a wall of dirt that is vertical that grows different crops. And in this case, this wall grew lettuce, spinach, chicory, basil, and tomato. And in order to apply its filtration system, it uses a gutter system, which you can see in the picture in the top and bottom, but slightly obfuscated by the results of the experiment, where the water will drift back, and it will drift back eventually back to the fish tank, to the filtration pump, which will then move back to the fish tank, and then, as you see on the top of the image, like on the previous diagram, you see that water goes back to the living wall, and it applies downwards through the growth media and back into the tanks. So it's in the same system in principle as previously, but it has more potential growth space for crops. And they experimented also with different media as well to reduce use of soil, because using soil generally will reduce effectiveness of the soil. There's greater chance of it being evaporated and not being used again for the fish. And as you can see from the graph, the results show that spinach has the most success in this kind of system, and that vermiculite has the highest total growth rate compared to others, which, for example, the mineral wool has extreme preference to spinach, but vermiculite has the most the highest average crop rate growth between all the crops that are used. Experiments 2 and 3 of this study used a very similar setup, where they both had 5 rows of 8 columns of 40 pots of single species plants. Experiment 2 did use basil, and it focus on inert fibers such as hydrocola, vermiculite, mineral wool, and coconut fiber, where the irrigated water from the fish tanks would flow through the top of several pops, and then it'll go down through the bottom, through the pipes that you can see on the image in top of the. And what was shown that the best performing row used coconut fibers, which had a average growth of 22. Performing row used the horticultural grade of coconut fibers as a substrate and had an average growth of 24.2 centimeters per pot compared to others. The graph itself compares the top row that's been watered to the bottom row. So A would connotate to the top row, B the second, C the third, and D the fourth, and E the fifth. So it just shows the distribution of growth from the water to make sure and check if any water may potentially be lost to be given to plants below. And this is shown, for example, in coconut fibers, where the first column had a growth increase of 28.6 centimeters, while the second column had a below average growth rate of 19.6 centimeters. So as you can see, as it goes down each row, the overall growth and advantage of increased growth reduces. The primary difference in experiment 3 is that I used trickery instead, which the average length of it in coconut fiber, which came out as the best, was 12.6. However, mineral wool came to a close second best, where in terms of height, it came to an average height of 10.8 centimeters. And in addition to this, it also measured the diameter, in which the basal diameter was not measured in the experiment. This experiment uses mixed research methods, as shown by the graphs previously, where quantitative data is used in order to measure growth, and as shown by the right of the experiment, also analyze the roots of the different crops that were used in the experiment in order to see how crop health has been established. Furthermore, this experiment uses a pragmatic framework. This is also shown by how they use a mixed method approach, but it also is demonstrated by the fact that they take into account primarily the practical applications of technology and trying to attempt to combine two technologies together in a system that creates a more diverse range of food than just crops alone, in order to provide fish as well as crops in order to help feed the cityscape. However, through missing other potential philosophical focuses in the study does miss out on some potential improvements that it could have made in its initial design. For example, if it took a more post-positive approach to it, they would also consider the fact that growth through both length and width alone is not enough to understand exactly how much of the crop you can feed to the consumer. So therefore, by taking the approach where you measure the dry weight of the crop, you will see exactly how much food you can feed people per square meter of land used. And you can compare that furthermore to the PEEP experiments that they are trying to improve upon, using vertical farming techniques to see whether or not there are realistic growth improvements from using this method as opposed to a method that they also, by not taking a transformative philosophical approach combined with a constructive approach, they would have been able to look at the application of a farm system context of, for example, creating a space for community to grow crops in and share and provide their own food with one another. And this can be done and applied to many different countries if you also focus on looking at cultures of each individual country and the general wealth and their history in order to help try and figure out the best way to integrate it. Because as with all research, the research itself is not useful if it not is accepted by anyone who it could help. This study both had theoretical and practical limitations. The primary theoretical limitation was the fact that they didn't consider potential effects that fish may have on the aquaculture system in vertical farming. They could have mentioned and applied a fish within this case study itself in order to see the overall effects that the system would have on the fish, to see whether or not the fish life can be maintained, especially when using these specific crops. And secondly, you can see the potential benefits that the crop system would have from ammonia supplied by the fish in the form of fecal matter, which the bacteria that some fish may produce ammonia and nitrates, which can be of benefit to plants in order to maintain growth. A practical limitation of this study would be, in order to apply it, you would have to consider the initial cost of producing these new farms with this new integrated system. For example, if you want to create one from scratch, in Canada, for example, it would cost about $229,000 Canadian dollars, plus any potential interest if they use the mortgage in order to develop it. You also have to consider the fact that because we are using additional technologies, this may also add to extra expenses upon the people who are making investment in the system. However, another consideration to make would also be the fact that you would need to consider land use efficiency, because if the fish tanks take so much space that the crop's profitability is reduced to the extent where the additional potential income by fish does not increase potential profits, then the system will not be applied at all. So by not considering the economic applications and the fact that you need investment in order to produce this system is very essential. However, it is important to also note that fish generally is more profitable as a venture than crops. Therefore, it does have great potential for profits, but it needs to be taken with a grain of salt, and you need to have this investment in place and have people willing to invest in place in order to make the study move forward. What I wish to investigate in vertical farming is to see whether or not we can integrate vertical farming inside apartment complexes within council property to ensure, firstly, that we help improve the financial situation of citizens who are under council accommodation to have additional food supply, which they can, and in addition to this, run a training program to help train individuals within the apartment complex to be able to operate vertical farms, and also potentially gain a new career in urban agriculture. And through running a case study like this, it would also aim to figure out a way to encourage tenants to both take part in vertical farming, even if it's not practical, but more on the basis of knowing what they want to grow within vertical farm and having it be community-based voting to ensure that what we grow in vertical farm is going to be used as opposed to wasted. Some studies have been done in the past in a much smaller scale within individual households to see whether or not vertical farming could be used, and it has shown that 39% of people in the survey that they did show interest in it, and the image to the right shows the setup that they used, which was very simple, and they did use census, and the people that were surveyed in this, about 6 out of 10, 6 out of 10, dude, 6 out of 17 people were perfectly fine and comfortable with using the census with a bit of training, which is what we will intend to do for tenants in a larger scale and have them work together. Primary safety issue would be the fact that it's a community-based farm. The best way to solve this would be to firstly have a training scheme in place which will offer tenants who are interested in it to learn and get the necessary health and safety training and operating procedures in order to properly use this farm for themselves. And as additional precaution, we can have a password locked door and anyone who's not trained within the health and safety systems, for example, teenagers and young children, which will also be in the apartment complex in order to get direct access to it. Also, furthermore, for core and legislative implications which you need to consider, the primary one would be that it would have to be new builds. We cannot do old builds because there'll be a risk of having to evict tenants that already exist within the apartment complex. And however, it would also be useful to consider potentially putting vertical farms in the basement level if you did want to create such a conversion. However, we have to also consider the potential of the architecture of the building itself, where quite often apartments, basement level areas where all maintenance facilities are placed within a apartment complex. This is infrastructure. Therefore, the deal would be to do new builds to bypass the need to first of all evict tenants, as well as you would have the added advantage of this will be that you can potentially attract new potential council tenants to a building who want this kind of vertical farming system in place, which would mean that would be more used compared to if people were just forced into it. The legislative implication would primarily be regarding funding of these farms in order to get them started in the first place. It is, however, important to also consider the fact that similar schemes have been done in the past for wider community-based things. For example, charities, usually in conjunction with the government, like with lottery farms, have supplied money to public green spaces to where food can be grown. In addition to this, there have been local government and charities also working together for systems. However, we do know it is possible to gain funding from this because in the past government has funded some of these schemes along with other charities like Lottery Fund, where would be another potential avenue of funding, where both have managed to create local green spaces where food can be grown. Local government has set out things like capital growth, which is a scheme in London where both the London Council and a charitable organisation work together in order to create and train people within a community in order to grow their own food and to grow food within allotments within London, and also to supply those allotments to people. This, the primary difference with vertical farming, of course, would be that it will be based in community within an apartment complex as opposed to a allotment, and there'll be a higher potential to grow food more efficiently, and also have the added benefit of training people into new careers that may potentially also help them get out of poverty in the first place. So, in conclusion, the best way to utilise and improve upon any research study is to consider 4 different research philosophies. And each philosophy has its own different individual way to contribute to a study, be it from making sure that quantitatively the research works successfully to being able to apply it to people and also encourage people to use and take advantage of the study that we used. And even though agriculture is considered hard science, we cannot abandon the soft sciences such as sociology, which can potentially be used to help encourage the businesses, government, and the public to accept new mediums of farming in order to help implement it to practice. Because vertical farming is still a relatively new subject and it still needs to be further integrated in other societies other than just, say, Japan, for example, where it has been widely used just based on the necessity of the fact that Japan's low in space. And they need to apply it to a different culture. We need to understand that culture in order to help. These are just reference slides.